Yeah. Okay. So this is a homework one, right? From the Xingli workbook. Yeah. So you did question 1 to 8. I think most of them were correct. It's just a bit of notation problem here. Midpoint, you should be writing. I didn't explain this during the lesson. I made a video. I hope you watched the video already. Capital M bracket bracket. That's how you get the midpoint, the notation. Okay, then most of it is fine except for here just a note. If you're giving a reason, you should put because. What you put here was a therefore symbol.
Okay.
Yeah, okay, never mind. Not so important. You can always use the English word. And okay, here you use the formula correctly, but there was an error carried forward with finding out your coordinates of D. So what you should, let's read the question first. They give you vertices of a triangle ABC. You got A, B, C, and unknown D. So what you should have done is to roughly plot out on the X and Y axis where the point A, B, and C are. So it's actually here, here, and here. Do you agree with the diagram?
Okay.
A is 0, -1. Actually, I just realized that my A is in the wrong position. Let me just edit this. Yeah, my A is in the wrong position. Let me try again. More accurately, it should be 0, -1, so it's somewhere here. Then C is 0, 7, so it's somewhere there. They are intersecting the y-axis. Then 7, 4 is somewhere there. So what we should have as our point D is actually somewhere over here, roughly. Then you get this shape, right? Does this make sense?
Yeah.
Can. Then what you need to do, right, when you're doing this plus thing, is to focus on the two what we call vectors that are the same. In this case, we want to focus on two vectors where one of those vectors involve the point D. And here is one such vector, here is another vector. In a parallelogram, we know that the opposite sides are equal and parallel, right? So that means that in order for us to travel from, let's say, point A to B, it will be a horizontal distance here followed by a vertical distance here. What is the length of the green and the purple? You already identified it as +7 and +5, right? So likewise over here, if you drew the diagram, you'll realize it should be going from point D towards point C. What you did was the wrong direction. You ran from C towards D. You see that? So just reverse the direction and you'll get the correct answer. So it's travel here and travel there. The green distance, the purple distance, +7, +5. So it should have been X. I just randomly call it X and Y. It doesn't have to be X and Y. It can be any other letter you like. X you +7, the green part. Y you +5, the purple part. So working backwards, Y +5 gives you 7. So if you work backwards, it's just -5. So 7 - 5, and you get 2. Likewise for this 0, you work backwards is -7, so it's -7, +2. Is it clear now?
Okay.
Then now we want to find the length of the diagonal BD. So yeah, it's just error carried forward. Let's just calculate it right now. So the length, I'll call it L, part 2. Square root of point BDB was what again? 7, 4. D is -7, 2. So it's just 7 minus away -7, bracket square, plus 4 minus 2, bracket square. Calculate, you get 14 square plus 2 square. I need a calculator for this. 14 square plus 2 square is 200. So square root of 200. You can split up as 4 times 50, right? Can you factor out another 4? Not really. Okay, so 4 times 50. So square root 4, square root 50. But wait, 4 can split out as square root 25, square root 2. 25 times 2. So what is square root 4? It's 2. Square root 25, it's a 5. 2 times 5, 10 times square root 2, which is 10 root 2. That's the answer. Can?
Okay.
10 root 2. Okay, then after that, we want to find out the area of the parallelogram ABCD. Sorry, I did not explain this during the lesson. I forgot about it. So I made a video for you. So for the area, what you do is you go anti-clockwise. That's my pattern. I like to go anti-clockwise. And you pick one point. I like to start with A, alphabetical order. A to B, then to C, then to D. And then don't forget, you need to go back to A. So here there are 4 points. So how many columns should you have in your crisscross shoelace method?
5.
5. Very good. Yes. Should always be one more than the number of points in the polygon you are looking at. So in this case, let's just calculate it. The area will just be 1/2 multiplied by the modulus of modulus. Means you just take the positive of whatever is the answer inside. Take the positive version. Positive stay as positive, 0 stays as 0, but negative becomes positive. Okay, so let's just do that. So A in this case is what's the coordinates? 0, -1. So you write down 0 on top, -1 below. X is always on top, Y is below. Next, point B is 7, 4, so 7 on top, 4 below. C is 0, 7, so 0 on top, 7 below. Finally, to D, the -7 and a 2 below. And don't forget, you need to repeat the very first point. Must have a repetition. Is that okay? Good. Then after that, down, 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 minus up, up, up. So like this. 1/2 multiplied by the modulus of the blue color ones is 0 times 4. Add on 7 times 7. Add on 0 times 2. Add on -7 times -1. Bracket, bracket. Oh, no space. Let me move a bit more to the left. Then you subtract away. Bracket, up. -1 times 7 plus 4 times 0 plus 7 times -7 plus 2 times 0. Close the bracket. Then modulus. Just key this in the calculator and you'll get your answer. I don't know what's the answer. Let me check. 7 times 7. That's a 56 minus -7. I'm just keying inside the calculator now. Yeah. Okay. Then half times. So half times 56 minus 56 is a 112 modulus. So this will just be 112/2, which is 56 unit square. This method is guaranteed to work if you use it correctly. Any polygon. Okay. Clear so far?
Yeah.
Can have you wondered why this formula works?
No.
No, do you want to know why?
It's gonna be very like
complicated. I cannot give you a good explanation at this stage. No, cannot. You will need to I give you the full I was so surprised when I finally found out the reason. It took me I learned this in Sec 4. I only figured out that there was a reason for it when I was in year 2 of university. That's how many years you go and count from Sec 4, 16 years old until year 2. I don't know, 22. Yeah. There was 6 years. I was suddenly, hey, how come the shoelace formula come out again? Oh, then I realized the reason. It's something called, I'll give you the name, Green's theorem. I can send you a link to a video that explains it, but you don't have the prerequisite knowledge to understand what he's saying. So yeah, we're just gonna skip the reason. Okay. Just remember that there's a fancy shoelace formula that is used to calculate the area of any polygon that just works magically. The reason why it works, tune in 6 years later, maybe you'll find out after NS, whatever. This is under calculus 3, or what we call vector calculus. Vector calculus. Yeah, you don't need to know it. Okay, moving on. That's all. Okay, so you only did up to question 8, is it?
Yeah.
Okay, can. Then I will continue going through some of the examples from the HW1. Should I go through that? Actually, let me see if I assign you any other. Okay, that's the only homework I have assigned. Let me double check. Because I want to introduce further what do you call it? Further coordinate geometry today already. So you can do more questions. Okay, I'll just go through a few more examples from that worksheet. From HW1. HW1, I will go through some examples. Then the rest will be your homework. I hope you have that file open. HW1 coordinate geometry Xingli. Let's look at question 9. Question 9. So the coordinates of 3 points P, Q, and R are 5, 6, 1, -2, and -3, 0 respectively. Show that P, Q, and R could be the coordinates of the rectangle PQRS. So I would want to draw a sketch first. Every time I hear rectangle, parallelogram, trapezium, I cannot take it if I don't draw a picture. Have to draw a picture. I don't understand how some students do it without a picture. I can't do that. So here's how I will do it. 1, -2 somewhere approximately here. Just plot all the points. -3, 0, so maybe somewhere here. It's not totally accurate. Just I'll make do with it. P, Q, R, then you can estimate somewhere, it must be S here, roughly, for a rectangle. Can you see that rectangle?
Yeah.
Okay. And of course, it should be a 90 degrees. It's just not drawn to scale. You have a S, question mark, comma, question mark. Okay, so we want to show that they can be the coordinates of the rectangle PQRS. So basically, what they're trying to say is that this angle here is 90 degrees, and you need to show it. All right, because that's a requirement for you to be a rectangle, right? You need adjacent sides to be 90 degrees. So we're going to show that they are 90 degrees. So find MRQ. What's MRQ? Gradient of the line RQ. So it's just y1 minus y2 over x1 minus x2. Then you get what? +2 over -4, which is -½ How about M semicolon MPQ? What would this be equal to? 6 minus -2, 5 minus 1. Answer is 8/4, which is 2. Then how do you show that they are 90 degrees? You take the gradient, you multiply by the gradient again. Then you get what? -½ times +2, which will give you -1. Then from there, you conclude, therefore, RQ perpendicular PQ. Now remember the negative reciprocal idea? Or you can also go one more step. MRQ equals to -1 over MPQ. So you have the negative reciprocal. So confirm they must be perpendicular. Okay?
Okay.
That's the first part. Sure. Then next, you want to find the coordinates of the point S such that PQRS is a rectangle. So you can do the trick again. Horizontal, vertical, horizontal, vertical. Do you want to try?
Okay.
Maybe I zoom in. Calculate. Just right. Good. So the x coordinate will +4 when you move to the right. Then +8. Yes, correct. Purple. So likewise for your R to S. Exactly, that's all. Right? Easy, just that's all. It's just +1 and +8. Okay, I don't need to show the working already. Just +4 and +8. Then -3 + 4 is 1. 0 + 8 is 8. This is the most efficient way to do it. Okay. Okay. Ken, that's S. That's all. Do you want me to show you the long-winded way?
Long-winded way.
Yes, the long-winded way.
What's the long-winded way?
You know the gradient of this line, and you know this is a rectangle. Opposite sides are also parallel. So we can also guess, we can deduce the gradient of RS. MRS will be equals to MPQ, which is what we found just now, +2. So now we got a gradient, we got a point. Can we find the equation of the line RS? Got gradient, got point, you can find equation of RS. And you just label R -3,0. Therefore, LRS can find already. It's just a long-winded, very long-winded approach to find LRS. How about LSP? Can we find LSP? Can. Why? Because the gradient of SP, I like to write down M then subscript SP, is equals to the gradient of RQ, right? Because opposite sides of a rectangle are parallel. And we already found out MRQ is -½ And we also have a point that the SP passes through, which is point P, 5,6. Then from there, we can find the equation of the line SP. Correct or not? So if we can find the equation of this line, how do we solve for the S? Simultaneous.
Okay.
Then you can solve from there. Get X, get Y. Do you want me to show you?
I think it's okay.
Don't need, you can try on your own. Very long-winded one. But this is the most efficient way. +4 + 8 +4 + 8. So easy. Okay. Don't need coordinate geometry. This is the true main takeaway that you learn from coordinate geometry at AMAX. Learning how to do simultaneous equations to solve for point of intersection. You will still need to use this in the future in other future studies of math or engineering or physics. Simultaneous equations. That's the main takeaway, to find the point of intersection. But this is just a fancy trick that works in 2D XY. I guess we'll just make do with it. Okay, can get the answer, can already, right? Right?
Yes.
Okay, 10, moving on. No, that's question 9. Still okay. Question 10, I think you can do that on your own. Question 10 homework. Question 11, do you think you can do it? Can, you can do question 11. Also homework. Question 12, I think I want to go through. Question 12, I want to go through because it involves perpendicular bisector. So what is perpendicular bisector? It means that you have a line like this, a point here, then you cut it in half, and you are 90 degrees. So it means it passes through what? This guy is what we call the M, the midpoint. Okay, so let's read the question first. Question 11. This purple color line is what we call the L perpendicular bisector. Okay, I don't write it in highlighter. Perpendicular bisector. Bisector of what? Bisect this line segment. Let's say we call this AB of AB. Okay, can. Let's just actually read the question. Okay, question 12. The vertices of ABC, triangle ABC are -4, 6, 8, -4, and 12, 16. So can you figure out where are they? Do you want to try? A is -4, 6. So maybe I zoom in. Okay, roughly there. And then another point is 8, -4. So here it will be smarter if you move your point maybe somewhere closer here. And then you label this is A -4, 6. Because now you have 8. So you need to double the 4, right? Then -4. So where is it? Yeah, close enough. So somewhere like this, and it will be 8, -4. That is your point B. How about your point C? 12, point C. +12. 4, 8, 12. And 16, go up or down? Somewhere high up, right? So roughly I don't know. 12, 16. And then you have your triangle there. Okay. Okay, let's just draw it in highlighter. Okay, yeah, close enough. Then find the equations of the perpendicular bisector of AB and BC. That guy there, correct. Oops, just use a pen. This is our perpendicular bisector of, I'll just call this L perpendicular of AB. Then, yeah, correct. Let's see. Let me copy down what you're writing. Gradient of AB will be this minus this over that minus that. 10 over minus 12, which is negative 5/6. Okay, that's MAB. But then what is the M of the L perpendicular? Perpendicular will be?
Negative 1 over.
So instead of this, maybe it's easier to think of it as times -1. Then after that, it will flip. So just do it in your head. Times -1 minus become positive, flip, then becomes 6 over 5. Positive. Can?
Okay.
Oh, sorry, it should be 5, 6 first. Oops. 5 on top, 6 below, then after you bring it up, it becomes 6 over 5. And should be a positive now. Okay, Ken. So 6 over 5 is the gradient of the perpendicular L perpendicular AB. What else we want? Equation of the perpendicular bisectors of AB and BC. So not enough, because it's a bisector, it also passes through the midpoint. So that's called this M of AB, MAB. So capital MAB, take note of the difference here. Little m is gradient, and we should write down. Little m is gradient, capital M is midpoint, is a point. In particular, the midpoint. So what would it be? It will just be equals to average of the x. So -8 plus 8 divided by 2. Average of the y, 6 plus -4 divided by 2. Simplify, you get 2, 1. Okay, 2, 1. So my diagram is not drawn to scale. It should be slightly above. A bit misleading, my diagram. So what I'm gonna do is, since I have an iPad, I can move my x-axis down a bit. Then it looks more accurate. Do you catch that? 2, 1 here. Can
Yeah.
Okay. Good. Then that's your that's your midpoint. So therefore, you can conclude what's the equation of line perpendicular AB. Oops, perpendicular of AB. It will just be the dot. Y use the point slope formula in this case, y minus 1 over x minus 2 equals to the gradient of that perpendicular, which is 6 over 5. That's it. That's the equation. Now you just simplify. So 6 over 5 times x minus 2. Then you add 1. So 1 plus 6 over 5 times x minus 2. Then you distribute 1 plus 6/5 x minus 12/5. 1 minus 12/5 is -7 over 5 plus 6 over 5x. Maybe you can bring it on the right side to make it look nice. Look like the mx plus c format. Okay, then that is your equation. Now we move on to the next one. What's the next one? Still under part 1, perpendicular bisector of BC. So this guy, not so accurate. Maybe somewhere here. I don't know. Then we'll label this as MBC. Oh, sorry, should be subscript. M, capital B, capital C, open bracket, question mark, comma, question mark. We're gonna fill in the blank. Here the 2, 1 should be beside the MAB. Oh no. Yeah, something like that. Okay, Ken, let's move on. So now do the exact same procedure. How do you find MBC? Let's find out that guy first, the midpoint. It will just be 8 plus 12 over 2, -4 plus 6 over 2. Simplify, you get 20 over 2, that's 10. 2 over 2 is a 1. Okay, 10, 1. Okay, 10, 1.
Okay.
Oh, by the way, since you know that it is 10, 1 already, do you notice that these both have y coordinate of 1? So what does it mean about my diagram? If I draw a line from MAB to MBC,
should
it
be
be
on the same. No, should be straight.
Horizontal, right? It should be horizontal, parallel to x-axis. Right? So yeah, that's the problem with sketching a graph. Your diagram may not be so accurate. So since I am on an iPad, I can select the entire diagram and rotate it around like this. There we go. Now it's more accurate. But you need to turn the y-axis around. So let me just move my line, adjust. Of course, you cannot be doing this if this was an exam setting. Yeah. So shift it here, shift it there, and then shift the y-axis. Now it's more accurate. Okay? Can?
Okay.
Horizontal. Only because I'm on an iPad, I can do that. Okay, Ken, moving on. So we are not done yet. That's the midpoint. We still need to find what? We still need to find, oh yeah, another point. Here, the y coordinate, you see, it's both 6. So actually, this should be a horizontal line, your AC, as well. I won't make the change already to the diagram. I think it's kind of horizontal. Can you accept that?
Okay.
Okay, good. Then M, that's coordinates of BC. What else we need? We need to find this guy L perpendicular of BC. We need the gradient of the perpendicular BC. So little m perpendicular BC, what would this be equal to? It will be the -1 over gradient of the original BC, right? So maybe we should find MBC first at the top. So let's just include one more line, sorry. MBC, it should be equal to y minus y, so 6 minus -4 over 12 minus 8. Type in the calculator, you get 10 over 4, which is 5 over 2. Therefore, the gradient will be -1 over, so it becomes -2 over 5. Times -1, and then you flip, essentially. This one becomes that one. Clear?
Okay.
Okay, good. So now, yeah, so now we have the perpendicular line as well as a point that passes through BC. So therefore, equation of the line perpendicular BC will be what? Maybe we try the, you write down. Continue.
Y minus 1 over x.
Correct. Yes, you got it. Okay. Now just to make it neater, something like that. Okay, then you times over. So just try and do it a bit faster. So you can times in, then -2/5x, then positive 210 over 5, that's a 4 plus 4. And then y minus 1 on the left. Make y the subject, so plus 1. Minus 2/5x plus 1 become plus 5. Okay, let me show you the other method. The other method is you let y equal mx plus c. But what's the m? It's just a perpendicular, so it's -2/5x plus c. Then now you can sub in a point that it lies on, that lies on the line. So sub in, what's the point? Midpoint is 10, 1. So therefore you get 1 equals to -2/5 multiplied by 10 plus c. Calculate this. 10 over 5 is 2. 2 times 2 is 4, minus 4 plus c. Solve for c, you get -4 bring over 1 plus 4, 5. C equal to 5. Therefore, y equals to -2/5x plus 5. Also the same answer. Okay?
Okay.
Can yeah. So just pick your poison, pick whichever one you want to do. Both are very long-winded. Anyways, so now that you have found the answer to these two lines, we have answered part 1. Now move on to part 2. Okay. You must keep on going back to your diagram when you're solving coordinate geometry. So it's a little bit troublesome. Yeah, so the coordinates of the point of intersection of the perpendicular bisectors of AB and BC. How? This one, no fancy trick for you to use because there is no quadrilateral. You literally need to do coordinate geometry to solve for this point of intersection, the yellow one. Okay? So yeah, let's try to do that. So what are our equations? Let's just copy it down so I don't need to keep scrolling up and down. So we have y equals 6/5 x minus 7 over 5 as our what's this? L perpendicular AB. And our L perpendicular BC, is it BC? Yes, is what we just found above. Y equals to -2/5 x plus 5. Okay, so now equation 1, equation 2. What do you notice? Both are y equals. Then you can just equate them straight away. 1 equals to 2. So therefore, 6/5 x minus 7 fifth equals to negative 2/5 x plus 5. Bring over the minus 2/5, you get plus 2/5. 6 plus 2 is 8/5. Minus 7/5, bring over, become positive 7/5. Add on the 5. I'll just use a calculator to make things faster. 5 plus 7 over 5. It becomes 32 over 5. And then you have 8x over 5. Both got over 5, so just compare numerator. 8x equals to 32. Divide by 8 and you get 4. Therefore, you can sub in the x equal to 4 into one of the equations. Let's just say we pick 2, because I see this one has fewer fractions, less scary. Then I'll pick equation 2. So y equals negative 2/5 times 4 plus 5. Let's calculate that. Negative 2 over 5 multiplied by 4 plus 5. And I get 17 over 5. Therefore, the conclusion is 4, 17 over 5. Answer. Ken?
Okay.
Clear? Good. Okay, let's move on. Oh, I need to start a new page. This is question 12. Okay, question 12 part 2. Then 12 part 3, radius of the circle that passes through the points A, B, and C. So in this case, I realized that I haven't go through this topic about circles. I guess this is a good time to introduce already. Through this example. Later, then I formally introduce. So let's take a look at the diagram again. They're asking you, find the radius of the circle that passes through the points A, B, and C. This guy. How? The trick here is to realize, let me just draw in the circle. I know it looks like an oval shape, but it's supposed to be a circle. Now, A, B, what do you notice? This is what of a circle? What do you call it? C, H, O. Chord of a circle, right? So when you got perpendicular bisector of a chord, right? Perpendicular bisector of a chord, what is the point that it must pass through?
The center.
The center, exactly. That is from O-level Emax. Likewise, for this other BC, it is also a chord. This other line B perpendicular of BC is also a perpendicular bisector of a chord. So it will also pass through a center. So just now, this was the answer to part 2. We found out the coordinates of this point. It's actually the what of the circle? This is the what of the circle?
Center.
Center of the circle. Very good. So if you know the center of the circle, how do you find the radius?
You
just call it point P.
You just use one of the points.
Which point? Do you want the red point? Do you want the blue point? Mike test.
Wait, how do you find the radius?
Okay, first you must know how does a radius look. Circle, there's a center, radius. If I draw a line like this, and then I draw a point on the chord, then I connect this. This is the center, I call it O. This is point A. Is this a center? No. Why? Because this line doesn't extend all the way to the point on the circumference. How about this other guy? If I call this point P, then I connect from O to P. Is that a radius?
Yeah.
Yes. Why? Because it goes from the center towards a point on the circumference. That's how you get a radius. Center to a point on the circumference. P is the center. Where are the points on the circumference? Is it the blue one? Is it the red one? No, those are points on the chord inside the circle. So which are the points that are on the circumference of this oval shaped circle?
C, A,
and A,
B.
and B. So you use any one of those points. Okay, then you will get the same answer. And then after that, you can find out the length of each of these line segments. Okay, the PA, the PB, and the PC, they will give you the same answer. The radius of the circle should be the same. So let's just check, assuming that I did it correctly. I was doing quite fast. 4, 17 over 5. Let's just label it. 4, 17 over 5. So let's calculate the length of PC. What would this be equal to? Square root of x minus x bracket square plus y minus y bracket square. By the way, the order of the x and the y and y doesn't matter. Just type in the calculator. I think this one. Yeah, okay, you can just type in the calculator and try to get an exact answer, I guess. But maybe it's not so important. I end up with the square root of square root of 1769 over square root of 25, which is 5. This is, let's just use decimals now. There's no point to getting the exact answer now. 8.411896338. Did you get the same answer? That's the radius already. But let's just verify if I did it correctly. Let's see what is PB. Square root of 8 minus 4 bracket square. Add on 17 over 5 minus -4, so plus 4 square. Let's see if this answer is the same. I got the same answer. You can also verify with PA. Is it the same? Can, huh? Okay. Yeah. So yeah, can so that's why you can find the coordinates of the center. So yeah, so that's how you find the radius. You just identify the center and then you find a point on the circumference. Okay, so I guess this question doesn't actually require you to know further coordinate geometry, which is equation of a circle. Later, then I'll talk about it. Okay, let me see if I have any other important questions I want to cover. Question 13, you can try on your own. Just a square. Question 14, have a ratio, also not too bad, but there's an unknown P and Q. Also quite easy. I just sub in x equals 0, y equals 0. You can solve for the unknown P and unknown Q. Parallelogram, you dealt with it already. Question 16, perpendicular bisector, you should be able to handle that. So the quadrilateral ABCD area, also quite okay. I guess the advanced one should be the one we should go through. 17 onwards. And then later got new trend. Okay, 17, 18, and 19. Pick one question.
17, 18, 19.
Huh? All three?
No.
Pick one. Then the other two will be your
17.
17. Okay, let's go through question 17. Let's take a look. So question 17 here, we have what? The coordinates of a triangle ABC diagram not provided are -4, -2, 2, 7, and 20, k. So again, draw the graph and try to make it slightly accurate. Don't have to be absolutely accurate like a graph paper. No need. -4, -2, so maybe somewhere around here. Point B is 2, 7, so maybe somewhere like here. Then 20, k. Wow, far away. Okay, that's no good. Let me just shrink it down. Maybe something like this. Something like this. And then 20, k is extremely far away. If this is 2, I need to go 10 times. So maybe somewhere here. I'm not sure. C, then 20, k. I don't even know the value of k, so I don't know how to go up or down. Just randomly plot a point. So now for part 1, they're asking you find the value of, oh, right, the triangle. I should draw the triangle. May have to change later. So part 1 is asking us to find the value of k if triangle ABC has a right angle at angle B. So 90 degrees here. So how?
You find gradient MAB, and then you take the negative reciprocal. Negative reciprocal, which would be gradient MBC, and then
and then you use gradient, then you can find k.
Correct. Yes, that's the correct way. Okay, let's just do it. So you got the idea already. Very good. So just 7 minus away -2 over 2 minus away -4. Then you get 9 over 6, which is 3 over 2. Okay, then therefore m of BC must be negative reciprocal, so -2 over 3. Right? Clear so far? Then gradient of MBC -2 over 3 must be equals to use the gradient formula. So k minus 7 over 20 minus 2. This becomes k minus 7 over 18, -2/3. Then k minus 7 equals to -2/3 times 18. 18 over 3 is 6. 6 times 2 is 12 minus 12. Bring the -7 over, so you get +7 minus 12 equals to -5. Answer. Okay? Find the value of k if triangle ABC has a right angle at B. Okay, done. Now prove that BC equals to AB. What does BC mean? What does AB mean? BC means you go and use the distance formula. Then 2AB means just 2 times of the length of AB. Then you just need to use distance formula or length formula 2 times for BC and AB, then show that BC equals to 2 times of AB. Okay, so let's just do that. Yeah. Part 2. BC will be, okay, let's just replace the k straight away with the -5. So x minus x square plus y minus y. So 7 minus -5 square. Take a square root. This one you want to show that it's exactly equals to 2 times, right? So it's strongly recommended to leave it in third form. So don't evaluate the square root. Just calculate whatever is inside. So we get 18 square plus 12 square, so 468. Good enough. I'll just leave it. I know I can simplify, but I don't want to. Not important. Move on to the next one. It's AB. AB is equals to square root of 2 minus -4 square plus 7 minus -2. Yeah, to avoid writing so many brackets, I'll just write down -2 minus 7 bracket square. Same thing. I'll get the same answer. So -117. Okay. Then I realized that here you can factor out 4. 468 divided by 4 is a coincidence that it's a 117. Then you can split up square root 4 square root 117, which is a 2 times square root 117. Then from there you can conclude, therefore BC equals to 2 copies of square root 117. Then you substitute the square root 117. So it's 2 times of AB. Sure. Can?
Okay.
Yeah, okay. Proven. Just follow the question format. Now we'll move on to part 3. This is still question 17. Part 3. Find the equation of AB and of BC. AB and BC. Okay. So I'm just gonna do it here. Use the for LAB. Just to save some time, I'm going to just use that point slope formula. Y minus, does it actually save time? I don't know. X minus 2. Then you equate to M of AB. Have we calculated MAB? Yes. Right over there. So just sub in, you get 3 over 2. Then we can simplify. Let's just do it. So y minus 7 equals to 3 over 2 times x minus 2. Multiply it in, and you get 3 over 2 x minus 3. Bring the 7 over, you get plus 7. 7 minus 3 is 4 plus 4. 3 over 2 x plus 4. Done. Can? Okay, LAB done. Now we need to find the next guy, which is the equation of line BC. So LBC, same thing again. Okay, can. So y minus what is BC? Just pick a point. Pick a point. Doesn't matter if it's point B or C. I like to pick point B because the number is smaller. So y minus 7 over x minus 2 equals to gradient of BC, MBC. But I know what's MBC already. It is just -2 over 3. Then you just times over. So y minus 7 equals to -2/3 times x minus 2. Distribute. Add the 7. Use calculator. 7 plus 4/3. 25/3. Can? Is that okay?
Mm-hmm.
Can? Okay, good. So you have the line AB and the line BC. That's good. So now move on to part 4. What did they ask you to do? In part 4, they ask you if the line AB intersects the y-axis at P, cut. And the line BC cuts x-axis at Q. Find the coordinates of P and of Q. So if it cuts the y-axis, I actually don't need a diagram. I know straight away y-axis, you just need to sub x equal to 0.
Mm-hmm.
Yeah, so that means that it's just +4 here. So that means P is actually 0,4. Then the other guy is sub y equal to 0. Yes, so sub, this one, maybe I write down a short instruction, sub x equal to 0. This one, the other guy is sub y equal to 0 because it's the x-intercept. So you get 0 equals minus 2/3 x plus 25/3. Times 3 on both sides, you get 0 equals minus 2x plus 25. So 2x equals 25, implying x equals to 25 divided by 2. So the point Q is 25/2, 0. Okay, good. That is your points P and Q. Now move on to part V. 5. Prove that angle APQ is not a right angled triangle. What's APQ? I have no idea. I need to go back to my diagram now. 0, 4, and 25/2, 0. When they say right angle, I no longer trust the math anymore. I trust the picture, or at least combined with the math. So, wow, talk too much. Okay, this point here is P. Where is Q? BC intersect x-axis. So that means my BC is this guy. Extend all the way until it reaches here. Here. That's my point Q.
Mm.
Here I noticed that 25/2 is what in decimal?
12.5.
What's the x coordinate here?
20.
So can 12.5 be on the right side of 20?
No.
Yeah, so that means my diagram draw wrong already. Probably, I could have made a mistake. Oh, right. This should be -5. So that means my point C should be somewhere below here.
Mm.
So I would like to make a more accurate diagram. So let me try and remove the highlights and move my point C down. -5. So somewhere maybe here. Close enough. And then you got the diagram. It looks more like a 90 degrees now. Yeah, so what were we finding? BC, right? So this is line BC. Now it makes more sense. Here is your 12.5, 0, or 25/2. Okay, so sometimes your diagram you draw the first time, it may not be accurate. Only after you do the math, coordinate geometry stuff, you figure out the value of K and stuff, then you can figure out the exact position of your points. So you need to update your diagram. Especially when it gets more difficult for these advanced questions, you should adjust your diagram, because here part V, we want to prove that angle APQ is not a right angled triangle. It will get a bit confusing if you draw your points P and point Q in the wrong position. Okay?
Mm-hmm.
How do you show it's not a right angled triangle? If it is a right angled triangle, what rule must it satisfy? What theorem must it satisfy?
Theorem.
What theorem?
Pythagoras.
Pythagoras theorem, right? C squared equal to A squared plus B squared. But here we can verify that that is not true. But so that's one way we can verify it's not true. We can show that it does not satisfy Pythagoras theorem. You take C squared here, you take A squared here, you take B squared there. You do A squared plus B squared, you show it's not equal to C squared. But in order to find our C, our A, our B, we need to do the distance formula, and then it's very long-winded, very slow. So if only there was a faster way involving 90-degree right angles. Is there a rule that we know of?
Gradient.
Yes, gradient, huh? So this guy and this guy, we can find out the gradient of AP, gradient of PQ, show that the product equals to not -1, not equal -1. Then it is no longer perpendicular. So do you want me to show you or can I just skip this? Find
Wait,
MAP.
what?
Find, okay, I think I just showed, huh? Basically, you want to show that the product of these two is not equal to -1. Therefore, it is not a right angled triangle. Okay. How you write it in math statement is like this: MAP multiplied by MPQ not equals to -1 if and only if AP is not perpendicular to PQ. So here, this is what we call the if and only if symbol. It means that they are equivalent. And you can do what we call negation. Negate the left, you negate the right as well. If you negate this one, opposite means you take the not equal version, the opposite of not equals. Oh, this is the symbol for negation. You can also put down a tilde like this. Then what's the opposite? It means you have MAP times MPQ exactly equal to -1. Still, if and only if, this becomes the opposite of the English. So opposite of not is, it is perpendicular to PQ. Does that make sense? Yeah, it's just funny notation to describe the true and false logic. Not equal becomes equal, not become is not become is. Okay, can anyways, so yeah, that's what we're gonna show. Eventually, this guy product not equal to -1, therefore conclusion AP is not perpendicular. Okay, so let's proceed. MAP is what? Y minus y, x minus x. So 4 minus -2, 0 minus -4. What do you get? 6/4, which is 3/2. Then MPQ, in this case, what would it be? It would be 0 minus 4, and then 25/2 minus 0, which is -4/25/2. This is -8/25. So from here, we can tell that, let me get rid of my P and Q. From here, we can tell something. What can we tell? We can tell that MAP, you multiply it by MPQ.
Won't give you -1.
Correct, yep. Not equal -1. Conclusion, AP.
Not triangle.
Not perpendicular to PQ, which means that you do not have angle, which means that angle APQ is not right angle. Okay, Ken. Then question 18 involving a kite question. Then that's all for this question already. That's part V, IV. Let me bring it down to make it look neater. Hold on. Oh, it's part V, sorry. Not IV. Whoops. Okay, what did I want to say? Yeah, question 18 is about a right angle isosceles triangle, and eventually you get a kite. And then part 9, question 19 is about a rhombus. Just to remind you on some properties involving those quadrilaterals. Here is a square. Here is a rectangle. What is the pattern? Stretch. Here is a square. If you push it on the side, what we call a shear transformation, you just slant it to the side. What you end up with is something like this, but slanted. Okay, it's sort of like pushing it to the side, so it gets squished. This is like slanted to one side. Let's assume that the 4 lengths still remain the same. I know it's not really the same, but you can assume it is. So this will be a rhombus. That was a square. That was a rectangle. Then can you see the missing shape here? What do you think it is? You stretch here, you slant here. what should be the last step?
Stretch one.
Stretch.
There.
Okay. You stretch the rhombus or you slant the rectangle. Either way, you will just end up
Parallelogram.
very good. Yes, you get the pattern already. Okay. Yeah, so it's a slanted rectangle, which is a parallelogram. Properties you need to know. 90, 90, 90, 90 for square and rectangle. For parallelogram, is opposite sides are equal and parallel. For rhombus, also same thing. Opposite sides are equal, but in particular, all four sides are actually equal because it's just a slanted square. Then you got parallel sides for the parallel opposite sides. But take note, it's no longer 90 degrees. Then what is a kite? A kite is really just made up of two isosceles triangles. Isosceles triangle at the top, isosceles triangle at the bottom. Okay, this is a kite. Is that okay?
Okay.
And still got one more shape. Trapezium. Trapezium means you got one pair of parallel sides. At least one pair. Just label the name, trapezium. Now there's actually a way to connect them all together as a family. Trapezium is the very big. It is the one that encompasses everything. A square is a trapezium. A rectangle is a trapezium. A parallelogram is a trapezium. A rhombus is a trapezium. A kite is also a trapezium. Okay, wait. Maybe kite is not a trapezium. Kite is separate branch. Everything is a special kind of trapezium. Did you know that?
No.
Okay, I need to send you a video. Send a video on explanation of quadrilateral families. Just a thing to take note is that the video is made in America. So North America. So they use USA. They use different language. So this is British English, okay? Trapezium. But in American English, they call this a trapezoid. Why? I have absolutely no idea.
Okay.
Yeah, just take note of the difference. Then some textbooks, they even mention, oh, trapezium must have a 90 degrees. I totally disagree with that. 90 degrees here, not required. For trapezium, the definition is at least one pair of parallel sides. At least. I'm not saying only one pair. I'm saying at least. So you can have two or more. Or I mean, you can have one pair or you can even have two pairs. Okay. This is all about a crash course on quadrilaterals. That's essentially all you need to know. There are other properties about the diagonals, and there are special formulas to find area of these quadrilaterals. Do you want me to go through?
Do I? Wait.
You may need to know.
Okay.
Can I go through? Okay, then now I need to start a new page. Okay, hold on a second. Let me just paste this. This time I don't focus on the opposite sides equal and parallel stuff already. Now I focus on the diagonals. It's a little bit different. So let me erase. Okay, now we focus on the diagonals. If not, it gets very messy. For the diagonals, right? Special case about the diagonals of a square. They bisect each other. Do you know what bisect means? Cut in half. So when I say bisects each other, what I mean is they cut each other in half. Does that make sense?
Yeah.
So it means that this length, same. That length, same. Also, by the way, for a special property about a square, this pink color is all about diagonals. Maybe I should mention. all about diagonals. This next page is, okay. All about diagonals of the quadrilaterals. I feel like I'm missing out on something. I'll get to it in a minute. I don't think I missed out anything for now. Okay, so bisect each other in half, and also for a square, the diagonals are equal in length. Equal in length. How about rectangle? Diagonal, diagonal. What happens? They also bisect each other. Okay, they also bisect each other. But it is no longer, oh, right, one more thing. Maybe I shouldn't write it so messily. I'll just say bisect each other. Huh? Then I'll put a small note that's a bit irrelevant. Bisect means you cut half. So here, diagonals, what are the property? It bisects each other. What else? They bisect at 90 degrees. Here's a 90, there's a 90, there's a 90, there's another 90. For not perpendicular. For rectangle, it's not perpendicular. I think you can tell, right? Here is obtuse, here is acute. Definitely not 90 degrees.
Yeah.
Then how about a rhombus? This is when it gets a little bit more complicated. Maybe I should try and make it a little bit more accurate. Hold on. Let me try and draw an accurate rhombus. Let me show you how I do it. Start with a circle. Okay. Wait a minute. I need to make my circle a little bit thinner. So start with a circle like this. Then after that, you identify the center, so somewhere here. Then you have a line like this. You have a line like this. Okay, so this is the two radiuses of the circle. Then what I do now is I copy and paste the circle. I make sure that I intersect at the point of intersection of these two lines. Then there's a center here. Since it's an equal circle, right? That means that this line here and this line here must also be the same radius. So all three lengths must be equal. Do you agree?
Yes.
Good. Then therefore we have constructed our rhombus already. Okay, using circles, we can construct a perfect rhombus. There we go. That's a perfect rhombus. Slanted square. Yeah, anyways, so let's draw in the diagonals. What do you notice? Do you think they are equal in length? For rectangle,
Equal in length.
Do you think they are equal in length?
No.
No, you can make it
I
a
don't
little
know.
bit. No, actually, the answer, you can make it a little bit more extreme. So you slant it even more. So something like this, 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 and then this. Look, I think it's very obvious now. Definitely not equal, right? Not equal. No, there's no optical illusion here. It is not equal in length. But what is special about it is that I need more space. Okay. Yeah. Diagonals always need so much space. Okay, not equal in length. What else? It is also bisect each other. They also bisect each other at 90 degrees. Okay. Can. So at first, for a square, you have these three properties: bisect at 90 degrees, bisect each other, and they are equal in length. But then when you slant it, you lose one of the properties. From equal in length become not equal in length, but the other two properties remain. So how about for rectangle? It's not perpendicular, it bisects each other, it's equal in length. When you change to a parallelogram, which one do you lose? Just now was equal in length, become not equal. How about here? Equal in length, you should also become
not equal in
length. Yeah, and I think it's quite obvious if you just draw the picture. You can see straight away. right? This guy is short, that guy is
Mm.
long. Okay. Yeah, so I'm just gonna copy and paste those properties. Not perpendicular, bisect each other. Equal in length is changed to not equal in length. Okay. And make sure they are not 90 degrees. What else? When I say bisect each other, I mean like, for example, if this is 10 cm, this guy is this is let me draw it more accurately. If this here is 10 cm, it bisects it, so it becomes 5 cm, 5 cm. Oh, then bisect doesn't mean you have to bisect at 90 degrees. You can be slanted like this. Oh, sorry, my handwriting is quite messy. Try and write it neatly. Bisect doesn't mean have to be cutting each other at 90 degrees here. It can always be at the point of the intersecting at the midpoint, but it's a bit slanted. So let's say that this length here was 8 cm. Then here it will be 4 cm, 4 cm. So that's what I mean when I say they bisect each other. Does it make sense? So this is a midpoint, but it is not 90 degrees. Yeah, so that is the properties about diagonals. Then interesting thing, one more about the kite. Kite here, they intersect at 90 degrees. And they also bisect each other. Bisect each other, bisect at 90 degrees. Are they equal in length? Not equal in length. Oh. How about parallelogram? Parallelogram is they don't bisect each other. Not in general, usually. Like, let me show you a more extreme example of a parallelogram. So maybe something like here, here, and then here. Like this, and then like this. They definitely don't bisect each other.
Okay.
Yeah, so this one for parallel of trapezium is don't bisect. Don't bisect at 90. Also they are not equal. May not be equal. Okay, so okay. That's for this kind of trapezium in particular, huh? But in general, there could be special cases of what do you call it, trapeziums that do satisfy the bisecting at 90 degrees and equal length properties for special trapeziums. Okay, let me just get rid of this. I'm just gonna remove this 90 degree. It's not relevant. Okay, remove. What else do I want to bring up? I want to bring up the area of a rhombus. Half times diagonal 1 times diagonal 2. Okay, so why? Let me show you. Is it a bit blur? Okay, maybe I can increase the quality of it. Okay, can. So rhombus, right? Let's see. It looks like a parallelogram, but please believe me, it's a rhombus. I want it to be a rhombus at least. Okay, so how do you find the area of a rhombus? What you realize is that they intersect each other at 90 degrees. Supposedly, okay, mine is more like a parallelogram, sorry. So how do you find the area? If we have the diagonal here, let's say this is length, the green color is D1. And you also have the purple color here, let's say is D2. What you realize is that because they bisect each other, that means that this length from this length here is just half of D2, right? Can you see that? Okay, and it is 90 degrees. So how do you find the area of the orange color rectangle? I mean, sorry, triangle.
Find the area of the orange triangle.
Half times?
Half times half D2 times
D1.
Okay, good. But what do you know about this other triangle here? The gray color triangle here.
Is half times half D1 times D2.
Half D1. Oh, okay. I mean, it's the same. Half. So basically, they are congruent, right? You can prove that they are congruent. So
Yeah,
really,
same.
to get the total area, you just need to take this times 2.
2.
Okay. So let's check what's the formula now. Half times 2. You're left with half D1 D2, which is what I was mentioning at the beginning. Okay. This is because of the bisect and perpendicular property. That's how you can use the half times base times height formula to find area of triangle. Only special to a rhombus, it's half times D1 times D2. Can?
Yeah.
New formula. Okay. You may need to use this. I don't know. Okay, anything else to bring up? I think you can do the rest as homework already. Can is it time? Okay, wait, let me see. AB parallel. Okay. Oh, that's a little bit difficult. Okay, I should go through question 21. Okay, let's go through question 21 now. Let's look at question 21. Bit difficult. So question 21, the figure below shows a trapezium OABC where angle OAB equals 90 degrees. So I would want to draw the diagram first. So give me some time to draw the diagram. Here, x-axis, y-axis. Maybe I'll bring it down a bit. We got a line like this. We copy it. Copy it down. Make it a little bit longer. Okay, then after that you extend here to here. And you're able to get this shape here. Okay, like this. And you have a point A, 90 degrees here, point B, 0, t. They start to use a lot of variables here already. Negative k, 3k. And then you got parallel line AB with OC. Okay? Now we want to answer the question. Read the question. The figure shows a trapezium, angle OAB 90 degrees. Coordinates of A and B are whatever is shown on the diagram, negative k, 3k, and 0, t. And k is more than 0. And the length of OA is square root of 90 units. So find the value of k. How?
OA is square root 90. Use the distance formula.
Yeah, which is?
Minus plus minus.
Tell me in full.
Minus k. Then plus. Oh wait, no, square. Then plus 3k square.
Yes, correct. So we also know OA is square root 90, so I'm going to equate this to square root 90 like this. Then I simplify. So square root of k square plus 9k square equals square root 90. So square root of 10k square equals square root of 90. Square both sides, you get 10k square equals 90. Divide by 10, you get k square equal to 9. K equals to plus minus 3. Which one do I reject?
Reject. Because you know that reject negative 3.
Since
Because
k is
then this will be positive. Then this x cannot be 3 because x is on the negative.
Yeah, but more simply put, you can read the question. They already told you where k is more than 0.
Oh, okay.
It was given. Okay. Yes. Yes. But yeah, your argument is correct. If you trust the diagram, it's on the left side of the y-axis. So that's why it should be negative and positive here. Yeah, it makes sense for your k to be positive 3. Negative 3 doesn't make sense. Okay, so k equals to 3 is your answer. Assuming the OA is length square root 90. So now part 2. The equation of AB. Equation of AB.
Okay. Okay. So now you have A. Now you know A is negative 3 and 9.
Yeah, correct. Negative 3, 9. Yes.
And then you can find gradient MOA. Then you take negative reciprocal, which would be MAB. Then when you have MAB, then you can do point slope formula. Then you get equation of AB.
What's the point? Do you use point A or point B? You say you use point slope formula. Which point do you use?
Use A, cause B got T.
Unknown T. Very good. Yes. Okay. Let me just write out whatever you said. So gradient here is, okay, gradient here will be 9 over 3 lah, huh? But with a negative. So it's negative 3. Okay. I just think of it as rise here is 9, run here is 3. So 9 divided by 3. But since it's downward sloping, must have a minus sign. Must have a minus sign. Okay, so that's MOA. How about MAB? Negative 1 over negative 3, which is just positive 1/3. Sorry, positive 1/3. Then you have a point A, which is negative 3, 9. So therefore, LAB is y minus 9 over x minus negative 3 equals to 1/3. Simplify y minus 9, x plus 3, 1/3. So y minus 9 equals 1/3 times x plus 3 equals 1/3 x plus 1. Bring the 9 over. So 1/3 x plus 10. Answer. Can?
Okay.
Good. Now let me just bring this diagram down so I don't need to keep scrolling up. Yeah, down all the way. Where am I? I am on part 3 now. This is question 21, part 3. Now, for part 3, the value of t. How? So since we already found the equation of the line, let me just copy it down. That's LAB. How do you find the coordinates of, how do you find the value of t?
You sub x equals 0 into equation line AB, and then y equals 10. Therefore, t equals to 10.
Very good. Yes. Actually, you can even go a bit faster. The y here is also t, so you can also replace the y with t. So sub x equals to 0 and y equals to t. Then the y can immediately replace with a t. Or you can even write down, instead of saying sub x equals 0 and y equals to t, you can just say sub b 0 comma t. Sub the point b comma sub the point b 0 comma t into line AB. Or if you don't want to call it line AB, you can call it equation 1, then you can also say 1. Same thing. Either way works. So you just get t equal to 10. Answer. Next, part 4. 2 possible coordinates of C if OC equal half AB.
If OC equal half AB.
Yeah. Let's just replace the t with a 10.
It mean like the distance.
Distance.
If OC equal half AB.
Oh, wait. Yeah, correct. We still don't know the coordinates of C. Yes. Then how? You got the distance. How?
Two possible coordinates.
Yeah.
Wait, this is 90, right?
Yes, correct.
Okay. Gradient OC is negative reciprocal of. Wait, actually, gradient OC is same as gradient of AB, which is
Yes,
just one
correct.
dot. Okay, one dot. Then, okay,
So it passes through the point O. So do we have the equation of line OC?
it'll just be
Yeah, correct. Yes. So LOC
y
is
equals to
just y equals, sorry, yes, dot y equals 1/3, then x plus 0. That's all. Then is that useful?
10. I don't know. I don't know. Oh, this is wait. What is? No, wait.
It's time to use one of the long-winded methods that I taught you before. Point C, call it A, comma B. Point C
Okay.
lies on the line OC. So what can we do now? Sub C, A, comma B into
Or into this.
exactly, because it lies on the line OC. So what do you get?
B equals to A over 3.
1/3 A. Good. So maybe we can make A the
use-
subject. So A equals to 3B. Oh. So this implies that C is actually
C is
AB, comma B.
okay.
Right? Okay, we have converted it from two variables, A and B, into a single, not variable, it's a constant. Two unknown constants to single.
Use
Then?
distance of line formula.
Yes, correct. This one is, wait, how come you concluded it's half of square root 90? Let me read the question again. Half of AB, what's the length of AB actually? Is it square root 90?
Wait, I thought I said half of A.
Oh, sorry. Okay, I see wrongly, I guess. Half of AB. Yeah.
Wait, is
yeah.
it half of AB? Wait, no,
Yes.
it's half of AB. Yeah, it's half of AB.
Correct. Half of AB. Yes. So what's the length of AB first?
Okay, find length AB.
Yes. Which is 3 square plus 9 square. Huh? No, 3 square plus 1 square. Right? Then you get 3 square is 9, 9 plus 1 is 10. So square root 10. So that means that OC is actually what? OC is actually half root 10. Okay, but wait, we know the coordinates of C, we know the coordinates of O is 0, 0. Can we find the length of OC in another way? Yes. Square root of 3 x minus x, 3b minus 0 square plus b minus 0 square, y minus y square. Simplify is just 3b bracket square, which is actually 9b square plus b square. Get 10b square. Is that okay?
Wait. Yeah. Okay. Yeah.
Can So
yeah.
A became 3b. Then after that, OC is OC. So that means square root 10b square equals to half root 10. What can I do now to solve for b? Here, if what you did was the following, let me show you. Square root 10, then you split out square root 10b square, then you split out as square root 10 multiply square root b square. Then you say, oh, square root and square cancel off, then you're left with b, right? You are wrong. Do you know why?
Why?
Because by definition, this is a definition. Square root of b square is actually the modulus of b. Modulus of b. Because you see, if b here was -3, then what is square root? If b equals to -3, Then b square followed by square root means what? Means you square first, then take the square root. Oh, but what happens after you square it? It becomes positive 9, right? Then don't forget the square root. So what square root of 9 is positive 3? Eh? So it means that a minus 3 turned into a positive 3. Did you see that? Which means that you no longer can recover back the negative 3 if you try to once you square then square root. It will no longer stay the same. It's not as simple as cancelling the square with square root and you get back negative 3. No. When you square, then you square root, you will get positive 3. So basically, negative turns into positive, which is the same as modulus. Okay, so you can have to leave it alone. So what I want to do next is square both sides. Okay, square both sides, what do you get? You're left with 10b squared equals to half. Here got half, you square, it becomes 1/4. Here got square root 10, you square, it becomes a 10. Is that okay?
Okay.
10 over 4 is 5/2, 10b squared. Then divide by 10, you get divide by 10, 5/10 is half, 1/4, right? Oh, actually, I could have cancelled off 10 straight away. Yeah, I should just do that. Don't simplify and I can cancel off 10 straight away. So b squared equal to 1/4. Then how do you solve for b?
1/4.
Square root of 1/4. What's missing in front?
Plus minus.
Plus minus, yes. That's how you can, that's why there are two possible values of coordinates of c. So this is actually square root 1 over square root 4, which is plus minus 1 over 2, half.
Oh,
so
wait,
if b is plus minus half, then yeah, it's not, there's no square root. It's simplified to just whole number. So therefore c is 3 times plus minus half, comma plus minus half, which is
so those are 2.
plus minus 3/2 plus minus half. Yes, I actually, to be more precise, it should be c positive 3/2 comma positive half, or c negative 3/2 negative half. Okay, can?
Okay.
Yeah, super long-winded. But it works. It works. Yeah. Do you know of any other? Can you see any other methods? That I can't see any other methods. Any faster way?
Okay.
Oh wait, there is one faster way. Sorry, I see it now. Okay, vectors. Using vectors. Let me draw another. Let me copy down the diagram first. Another method that we could have done this is the following. So we know the length of AB is square root of 10 already. Let me just erase the erase all the details so it doesn't get so crowded and confusing. Yeah, half AB. We know the length of AB is square root of 10 already, but can you see that there's a horizontal followed by a vertical here? Can you see that? Can. So what's the distance traveled? Plus 3 here, plus 1 here, right? Then if you have square root 10 as this length, it translates to a plus 3 horizontal and plus 1 vertical movement. How about when you have half the length and it's still parallel? This is half the length. What do you think is the horizontal movement and the vertical movement now? When you half the length, the horizontal
plus
and vertical
1.5 plus 0.5.
Yes. So that means that your coordinates of C will be what? 1.5, 0.5. That's one possible answer. What's another possible answer is your point C could be in the opposite direction. It could have been, if I use pink color, pointing the opposite direction. This could be your point C. I'll call it C with a line on top for the C, the evil twin. It will be the opposite direction now. So I hope you can see the green and the purple. But now you're going towards the quadrant 4 already, right? the place where there's negative x and negative y. So you should be plus 1.5 here if you move from left to right, and then plus 0.5 here. But now you need to walk backwards. So it should actually be negative 1.5, comma, negative 0.5. Can you see that? Let's check. Is it the same as our answer? Oops, wrong way. Let me swap it around so it's easier to draw my highlighter. Looks nicer. Can you see that they are actually the same answers? This guy is this guy. That guy is that guy. Can see or not? That's the faster way to do it, using vectors. When you halve the length of AB to OC, the horizontal vertical movement will also get halved. But then you need to consider the two possibilities. Your point C could be here. Okay, then your diagram is like this. This is your other trapezium. Can you see the other trapezium?
Yeah.
Okay, yeah. Okay, now time to introduce new topic. The rest will be your homework later. Then I message you.
Okay.
In the worksheet. Now time to start a new topic. Let me send you a file first. Hold on. Stand by. I'm going to send you a lot of files. 5 in particular. Oh, where's your link? Okay. Brandon. Click and drag over here and send. On Telegram, yeah. Oh, it's taking a while to load. Yeah, the next topic we'll be looking at is the, what do you call it? Equation of a circle.
Okay. Equation of a circle.
Equation of a circle. Yes. I want you to download the which one is it? 1.1 lesson coordinate geometry examples.
Okay. 1.1 examples. Okay. Yeah.
Then yeah, once you have it open the file, there's 6 questions.
Yeah, I have it open.
Okay. Should I just label below? Yeah, I'll just continue writing it. This one, I'll just put in the same file. Further coordinate geometry examples. It's basically equation of a circle. So what is a circle? A circle like that. Okay. That's a circle. That's a circle. So what's so special about a circle is that there's a center here and then there's a radius.
Okay.
That's in geometry. You learn about area, pi r squared, where r is radius. Circumference, the length of the circle is 2 pi r. Or you can also say pi times d, where d is diameter, 2 radiuses, 2 times radius. That's good and fine, but here we are gonna look at the equation of a circle, which means we're gonna put them on our x and y axis. Like this and like this. X-axis, y-axis. Now, the key thing to take note of over here is that let's just for simplicity's sake, let's assume that the radius here is equal to 1 first.
Okay.
Then this point here will be x comma y. Then can you see that there's a right angled triangle over here? Can you see it?
X comma y.
As a point here,
Okay.
Then there's a right angled triangle. That's a more important point to take note of. So what's the length over here? The blue part.
X.
Good. What's the vertical length over here?
Y.
Good. So that means you can form Pythagoras theorem already, right?
Okay.
What's the equation? x square plus
Plus
y square
equal 1.
equals 1. That is the equation of a circle.
X square plus y square equal 1.
When the radius is 1.
Okay.
What if I change the radius now to, okay, I should draw a different circle. Let me shrink it down as well, so I don't have to occupy so much space. What if I change the circle now to radius 2? Then again, you can draw the same setup, but just have to replace the 1 with a 2. So now it becomes 2. Then you have Pythagoras theorem tells you this should be 2 square. Hey, where's my pen? 2 square. Yes? Then in general, if you just keep on changing the radius, what happens? It just becomes x squared plus y squared equal to something square, something square, something square. In general, it will be radius squared. Do you agree?
Okay.
Now? Good. Okay. Now, so why does this Pythagoras theorem give you the equation of a circle? What you can do is you can try to make y the subject here, right? Making y the subject. Let's work with this more complicated 2 square first. If y is the subject now, what do we need to do? We need to make y squared a subject first. So 2 square minus x square. I know you can factorize as a minus b, a plus b, but there's no need to do that here. Then make y the subject. So you have to take the square root. Huh? When you take the square root, what do you need to introduce here?
Plus minus.
Plus minus. What does this plus minus refer to? When y is a positive, when y is a negative. Which part of the graph will give you positive y? The top or the bottom?
Top.
The top part, right? So that means if I just split this up, I get y equals to the negative square root versus y equals to the positive square root. It's actually referring to the top half of the graph and the bottom half of the graph. Okay? This formula here, I mean, let's just focus on the brown one, the positive one. If you plug in different values of x, right, you will be able to obtain the corresponding y. It's a formula. You can draw a table of values, right? Just like when you're first starting out learning about y equal mx plus c, if you remember from sec 1. You have a different bunch of points. You just plug in -2, then what's the y value? Negative 1, then what's the y value? Don't know, question mark. 0, what's the y value? 1, 2, what's the y value? What's the y value? You just plot a bunch of points when you're learning the equation of a straight line y equal mx plus c. Now we can do the same thing, but I'm not going to bore you. I'm just going to tell you some of the more important points here. Make a good guess. What do you think is the coordinates of this point here? I'm circling in red. Can see?
Okay.
What do you think is the coordinates of that point? It cuts the x-axis, so which one should be 0? X or y?
Yeah, y should be 0. And
Y should
x will be the radius.
2, right? Very good. How about this point here at the top? This point here.
0, 2.
0, 2. Then the next point here.
Negative
2.
-2, 0.
Very good. Then this bottom point.
0, -2.
Very good. Okay, so now that's the equation of a circle. Basically, right, when you have these two equations, they are giving you all the coordinates of the points that lie along the circumference of the circle. So all these different points. Or you just plug in different values of x, you'll be able to get the corresponding y coordinate. And then that corresponds to every single point along this line. Okay?
Okay.
That's the equation of a circle. But that is only assuming so far that the radius is 1, radius is 2, or radius in general is r squared, and also a hidden assumption that the circle is centered at 0. Or the origin, sorry. What if we move the circle now? Okay, I'm gonna make your life more difficult. I'm going to move the circle. So instead of having it nicely at the center like this, I'm gonna move it a bit. So let's say that now it's at the point 1, 1. What's the equation of the circle now? Assuming the radius is still 1.
So what? And then it's like always be
Oh, you got the right idea already. But it's the other direction, -1. One square. Exactly. That's the equation.
okay.
Okay, you can verify that. So let's just figure out what are the coordinates of the few points here at the top, at the bottom, at the right, and on the left. What do you think will be a point here? If it's radius 1, it will be
1, 1.
no.
Wait,
Center is 1, 1.
2. Wait, 2, 1.
2, 1. Okay, can I just maybe because of the way I draw my diagram, can I just change the radius to let's say it's 3. Okay, radius 3. So the equation now is not 1 square, it's 3 square.
Okay.
Then what would be the coordinates of the point on the right?
4, 1.
4, 1, exactly. How about the point on the top?
1, 4.
1, 4, correct. Then how about the point on the left?
-2, 1.
Good. The point at the bottom?
-1, -2.
Very good. Much better. Okay. Can. So you understand now, you just have to okay, let's just try another example. How about if I have my center at a negative value? Let's say, for example, I just redraw the whole thing. Wait, like this. If I have a point over here that's -1, -2, then I draw a circle so that it has radius 5. Okay, radius here is 5. Then what's the equation of the circle?
The equation of circle.
Yes. Here the key trick is to x minus away the x coordinate of the center, n square plus y minus away the coordinate of the center, y coordinate of the center square equals to, sorry, not plus, equals to radius square. Okay, good.
Okay.
So simplify, we get x plus 1 bracket square plus y plus 2 bracket square equals to 25. Yeah. But it's more important to make it a 5 square lah. So let's also figure out, just last exercise already, before we start the actual questions, what are the coordinates of these 4 points? Let's say the right point here.
The right point would be 4, -2.
The top point?
-1, 3.
The left point?
-6, -2.
Oh, sorry. Could you give me a moment? I need to go and get my charger.
Yeah, sure.
Oh no. Wow. Oh. Sorry. I forgot to check the charge battery. Okay, this might take 3 minutes. Is that okay?
Yeah.
Sorry. Okay, in the meanwhile, you have the exercise with you, right?
Oh, yeah.
Yeah, maybe you can try question 1. Yeah, I think you can handle that already. Equation 1 is quite easy. Find the equation of the circle with center 1, 2 and radius of 8.
X minus 1 square plus y minus 2 square equals to 8 square.
Okay, good. Then how about question 2? Yeah, it's correct. Answer for question 1. How about question 2? A circle has center negative 1, 1 and passes through 2, 5. So it means 2, 5 is a point that's on the circumference of the circle.
Okay.
Then find the equation.
Find distance from center to the 2, 5 point.
Correct.
And then when you find distance, then that's the radius. And then the equation will be x plus 1 plus y minus 1 equal to the radius square.
You mean after you minus, you still need to square, right? Minus negative 1, then bracket square, plus y minus 1 bracket square. You forgot to mention the square. Okay, yes, you got the idea. Good. Okay, hold on a second. Sorry, you were saying?
Determine if 3 lies on circumference. Or just sub in x equal 3, y equal 3.
3. What is 3? Yes, correct. Just sub in x equal to 3, y equals to 3. Then you will see. It may. Okay, let me just do the question. So do the example. So for just to fill in the blanks. I forgot to fill in. Yeah, here. Can you? Wait a minute. Let me just. Oh my goodness, where did it go? Yeah. Sorry. Can you see the screen?
Yeah.
Okay, good. Let's just finish up labeling the coordinates of these points. So -1, -2, you move 5 units to the left. So that's why -6, -2, and this one you move 5 units down. So x coordinates stay the same, but -7. Okay, good. Then yes, you were saying that question 1, just fill in the blank. So you get x minus 1 bracket square plus y minus 2 bracket square equals to 8 square. That's good. Question 2, yes, you just find the length of the radius. So radius equals to square root of -1 minus -2 bracket square plus 1 minus -5 bracket square. This simplifies into, what is it? 3 squared 9. This is -4 squared 16, which is 25. Square root 25. Actually here, you don't need to evaluate the square root because all that we need in our equation is the radius squared, right? So all we need is radius squared, which is just 25. And therefore, equation of the circle will be x minus -1 bracket square plus y minus 1 bracket square equals to 25. X plus 1 bracket square. Yeah, that's the part 1. Part 2, Part 2, determine if 3 lies on the circumference. So you can sub in just x equal to 3. Don't try to sub in the y equal to 3 because it is possible that you will end up with something that is not. Okay, how do I say it? How do I phrase this? You may not be able to solve the equation. You will end up with square root of -1. So try not to do that. So let's just sub x equal to 3. What do we get?
You get
this guy, right? Everywhere have x replaced with 3. So 3 plus 1 is 4. 4 squared is 16. add on y minus 1 bracket square equals to 25. 25 minus 16 is 9.
Square root.
Square root plus minus 3. Then you have to make y the subject. So you have to plus 1. So 1 plus minus 3. Or in other words, y equals 1 minus 3 or y equals 1 plus 3, which is negative 2, which is positive 4. Do you get 3?
No. Y
So that means,
does not equal 3.
yeah, so which is
Does not lie on the circumference.
does not positive 3, and therefore 3 3. Yeah, correct. Does not lie on circumference. Circumference of circle. Okay. Yeah, so actually you can draw a quick sketch and you'll know what is going on already. So x-axis, y-axis, where's the center? Negative 1, comma, positive 1. So somewhere over here. Let me just move it to a good position. Maybe somewhere here. Then you just draw a circle of radius 5. Here, sometimes you may need to determine how big is your circle when you're sketching. What's the distance over here? This diagonal. It will just be 1 square plus 1 square, then take a square root, right? Which is square root of 2, 1.414. So 5 is bigger than 1.414, so you should draw a circle that's slightly bigger. Like this. So approximately like this. Something along the lines like this. Or along the lines of this. So when we sub in x equal to 3, oh, by the way, here, what's the end point here? Or along the horizontal. The y coordinate should be the same, but radius of 5, right? So what should it be now? Minus 1 plus 1? 4, 1. So where is x equal to 3? It's actually this vertical line here, right? This is x equal to 3. Then we are trying to find out the intersection here. That's what I'm doing. I sub x equal to 3, I'm trying to solve for the y coordinate of this point. So I figure out it's 3, 4, 3, negative 2. So where is 3, 3? It's actually somewhere over here, which is inside or outside the circle.
Outside.
I don't know. Inside means here, this region is inside the circle. Outside means
inside.
3, 3 is inside the circle. There are certain questions that you may encounter in the future that will ask you, you have a certain point, 3, 3. Is it inside the circle or outside the circle? Then this is the trick to do it. You figure out one of its x coordinates, sub in x, then you find out its corresponding y coordinate. Then if it's smaller, it's inside. If it's bigger, it's outside. Here we found our corresponding y coordinate. Our corresponding y coordinates is 4 to negative 2, which can sandwich the y coordinate of 3. Right? 4 is bigger and negative 2 is smaller. So definitely it's inside. Based on the picture, I think it's quite obvious. Another way that you can figure out that 3, 3 lies inside the circle is to measure the distance from its center. Measure the distance between the center and the point itself. If it's less than the radius, if it's equal to the radius, or it's more than the radius, we can conclude what? Let me write this down.
Whether it lies on circumference or is inside the circle or is outside.
Center to point, we measure the distance or length. If it is 3 cases, less than radius, I'll just use R for radius, is that okay? Less than R, equals R, more than R. From there, we can deduce 3 things. Yes, what you said is correct. Okay, maybe I should write it at the bottom. Because this is quite important. You will need to know this trick. Distance between center to a specific, to a point A, to a point A. If it's less than R, equals R, or more than R, we have 3 conclusions. Less than R means that it will be inside the circle. Inside circle. Equals R means on circumference of circle. More than R means outside circle. So inside, outside, or on? That's all. Yeah. Quite simple, I guess, if your geometry is okay. Okay, we are. Let me just make it look nice. Yeah, something like that. Okay, good. Let's just put it at the corner. Okay, moving on to the next question. What we have, question 3. Question 3 says, a circle has the equation x squared plus y. Sorry, x squared plus y squared minus 10x plus 6y plus 9 equals 0. Find the coordinates of the center and radius of the circle. How do we do that?
Change
Complete
to
the square.
the
Remember, we need this format, x minus, oh right, did I not give you the general format? Sorry, I need to give you the general equation. So in general, when you have a circle that's in the middle of nowhere, P comma Q as the center, let's just call it C for center. Then you have a circle like this. Okay, I'll try to make it look accurate. And then you have y-axis, x-axis. Then the equation of the circle is always x minus p bracket square plus y minus q bracket square equals to r square, where p comma q is the center and as radius equals to length r. Okay, that's the equation of a circle. Clear? Good. Move on. Okay, now how do you get the x minus p bracket square? How do you get that y minus q bracket square equals to some radius square? You just need to complete the square. This is a key trick. Complete the square. You know how to complete the square, right? Yes, recap. So what you need to focus on is the x first. How do you get x minus p square? You need to focus on your x square and your minus 10x term. So this is what we call the power 2 quadratic. This is what we call the linear. Bring them together if you are confused. So as a beginner, I guess just do that first. Then next one, you bring the y square and the y together like this. Then the constant 9, just bring over to the other side. Can see the pattern? X together with x, y together with y, then constant on the right side. What you do next? Complete the square. So x squared minus 10x, just take, I see a x square, I just copy down x. I see a minus, I just copy down a minus. I see a 10, I see a x, I ignore the x, I focus on the 10. I copy down, but I divide by 2. Bracket, power 2. Minus away, this number I know is 5, but I just want you to see the pattern in general. Bring over, 10 over 2. Bracket, power 2. You try to expand this, you will get back x squared minus 10x. Guaranteed.
Yes.
Plus, next one, try. What would it be? Y squared plus 6y. Complete the square?
Y square.
No more square. Open bracket y. Plus?
Y plus 3.
3, yes. Close bracket.
Minus 9.
Oh, square, right? Must have a square first.
Mm.
Minus, how do you get 9? 3 square. It's like, for now, I need you to, I know it's 9, of course, but I need you to see the pattern because the number will change to become very ugly very fast. It can become 7 over 2, then 7 over 2 square. You can't calculate 7 over 2 square so quickly in your head. Okay, maybe you can, but I want you to see the general pattern. You basically square that number you divided by 2. Or even more generally, it's not 3. It's 6 over 2, bracket 6 over 2, then square.
Okay.
So of course, yeah, you can simplify straight away if you're fast. So x minus 5 bracket square, go ahead and simplify straight away if you're fast. Then you get y plus 3 bracket square minus 3 square. Even faster, then you can skip directly to this step. X minus 5 bracket square minus away 25 plus y plus 3 square minus away 9 equals negative 9. Then what do you do now? You see constants here? Throw away. I don't want them. I want them on the right side only. So I'm left with this. Negative 9 plus 25 plus 9. Coincidentally, the minus 9 and plus 9 cancel off. Usually they won't be so nice. I just pick a good example. And then you get 25. Wow, what's 25? It's 5 square. Then from here, can you deduce what's the center and what's the radius? What is it?
5, negative 3.
Good. Then the radius?
5.
Yeah, correct. Exactly. Good. Okay, you understand already. So yeah, now let's move on to question 4. Go, go, go. Let's go and see if I can finish all the examples. Question 4. Find the coordinates of the center and radius of a circle with the following equation. X squared plus y squared minus 2x minus 4y plus 5 equals 64. First thing, plus 5 bring over. So you get
Yeah.
this 4 minus 5, 59. Then what else do you do? Complete the square. X squared minus 2x, what do you get? X minus?
X minus 2 over 2 bracket close square
Minus? Then continue.
Then
Copy and paste.
2 over 2 square.
Bracket. Square.
Then plus y minus 4 over 2 square minus 4 over 2 square.
Yes. Okay, that's it. Good. Okay, you see, basically this guy and this guy, you get this guy and that guy. This guy and this guy, you get this guy. Does it make sense?
Yeah.
Okay, good. So equal 59. But we need to simplify it now. Then x minus 1 bracket square minus y 1 square is just 1 plus y minus 2 square minus y 2 square is 4 equal 59. So x minus 1 bracket square plus y minus 2 bracket square equals to minus 1 minus 4. Bring over, plus 1 plus 4. What do you get? 64. Can?
Oh.
Can? Okay. Maybe I
Yeah.
show the working first. Wait, in case you are confused. 59 plus 1 plus 4. Like for now, you can remember. Maybe 1 week later you forget. I'll just write down the working. Then equals to 8 square. So what's the center? What's the radius now?
1, 2, and then radius 8.
Yep, exactly. Can? Easy? Good. Next. Haven't got to a difficult question yet. This one only basic example. Question 5. Find the radius and coordinates of the center of this equation. 2x squared plus 2y squared minus 3x plus 4y plus 1. Oh no, how come now? Just now, if you pay attention, you got 1x squared, 1y squared. 1x squared, 1y squared. You realize that now it's 2x squared, 2y squared. Why is so weird? Then how to complete the square now?
Divide everything by 2.
Is that a good idea? Okay lah, can. Okay. I am very scared of dividing by 2 because I'll introduce fractions, but okay lah, not too bad. Then let's bring them together since it's getting a bit scary with a lot of terms. Like this. X squared with x, y squared with y. Constant. What do you do with constant?
Bring over.
Bring over. So bring over, you get minus half. Negative half. All right, then how do you complete the square for this first two?
X minus 3 over 4 square.
Yep. Plus. Wait. You see plus sign, you
Oh yeah, plus.
copy down the plus. And it's 2 over 1, just simplify straight away is 1. Okay, then minus square, then minus 1 square. Okay, equals to negative half. Simplify. X minus 3/4 bracket square minus away. Wow, I need a calculator for this. Minus bracket fraction 3/4 square plus minus 1 square. So this and this, I just use a calculator straight away. I get a negative 25/16. Then I add on a y plus 1 square. Can?
Okay.
Then the minus 25/16 bring over. So what do you end up with? With the power of an iPad, I can copy and paste. This one also can bring over like this and plus. Faster. So 25/16 minus 1/2. And you end up with 17/16. But that is just square root 17/16, then square. Which is the same as square root 17/4 bracket square. Is that right? Okay, good. So now tell me what's the center and tell me what's the radius.
Center 3/4, comma, -1.
Radius?
Radius square root 17/4.
Yeah, exactly. Okay. So it's getting kind of late. Let's finish up one last question. Is that okay?
Yeah.
Okay, question 6. Show that the line 4y equal x minus 3 touches the circle. Hence, find the coordinates of the point of contact. So what do we mean by touches? It means tangent. Do you remember your b square minus 4ac?
Okay.
Which one? Which one?
Equals 0.
Equals to 0. So we need to get a quadratic equation. How do we do that? First step must always be simultaneous equation, substitute. Is that clear? Can? Okay, so let's write that down. 4y equal x minus 3. I think it would be smart to make x the subject here. We can avoid fractions here. So let's call it equation 1. Then we have the second equation, the circle. You can choose to complete the square and proceed to get the equation of a circle. But this question is actually a hidden discriminant question. This is an equation of a circle, yes, but it's not very relevant. So completing the square and getting the center, getting the radius is not super relevant. What we should do instead is do simultaneous equation. So what can we do? Sub 1 into 2. Okay, let's see what happens. We'll end up with x becomes 4y plus 3 bracket square plus y square minus 4x. Oh, sorry, the x replace 4x minus 8y plus 3 equals 0. I'm just going to copy and paste so I can save some time. Can? So open up the bracket now. 4y plus 3 bracket square. What do you get? 4 square 16 y square plus 2 times 4 is 8. 8 times 3 24y. 3 square is 9 plus y square minus 4 times 4 minus 16y. 4 times 3 minus 12 minus 8y plus 3 equals 0. Combine like terms, what do you see? 16y square, 1y square, 17y square. Combine like terms, what do you see? 24y minus 16y minus 8y. What a coincidence, plus 0y. Combine like terms, what do you see? I see a 9 minus 12 plus 3. What a coincidence, is a 0. Was that meant to happen? What a coincidence. We don't really have much of a quadratic to solve. So what we are doing now is really just a simultaneous equation to solve for x and y. And since we already got 17y square equals to 0, solve for y, what do you get? What do you get for y? Mic test, can you hear me?
Yeah.
What is y?
0.
Yes. If y equal to 0, we can now sub y equals to 0 into equation 1. What do we get? X equals to 4 times 0 plus 3 equals to 3. So that means 3, 0. Oh, so this is the point. Okay, so it means that we will obtain, actually over here, once we get this, right, we can actually show that it is a tangent by using b squared minus 4ac. In this case, it's 0 squared minus 4 times 17 times 0, which is equal to 0. Oh, so since it is equal to 0, therefore we conclude it is tangent. Can? The A, the B, and the C, is it okay?
Yeah.
Okay, yeah, then that's how you show that it's tangent using b squared minus 4ac. Then after that, you just solve for x, solve for y, and you are able to obtain 3, 0 is the point of tangency. Point of tangency. So just a quick example, one more thing I want to show you is the equation. So you got 4y equal x minus 3. That means that you have y equals to 1/4 bracket x minus 3. And then you have the equation of the circle. Let me show you digitally on a graphing calculator online. Graphing calculator, cut decimals, and show you how it will look. I want to show you the tangent over here. So let's key in the equation. We have y equals to 1/4 bracket x plus 3. This is the equation of the straight line. And you also got the equation of the circle, x squared plus y squared. And then minus 4x minus 8y plus 3 equals 0. There you go, that's a circle. Oh, wait a minute, something is wrong. Oh, it should be a minus, sorry. There you go. Can you see that the equation is tangential to the circle?
Yeah.
Touch 1 point only. Okay. Okay, that's all. Oh yeah, one more thing. You can also play around with decimals. You can key in equation of a circle by typing in x minus a close bracket. Then number 6 on top, there's a caret, that's a power 2. Then you can also put in plus y minus b close bracket power 2 equals to r power 2. Then you see the a, b, and r. You just select them, a, b, r. Then you get an equation of a circle. You can play around with the value of r. Then you change the size of the circle. Move the b, then you move it up and down. Move the a, then you move it left and right. Can understand?
Yep.
Yeah. Then you can just use decimals to go and explore equation of a circle. Okay, that's all for today. Okay, thank you. I'll send you the homework later.
Thanks.
Thank you. Bye-bye.
Bye.